Hello guys, this is Great Garcia and I'm going to go over your review. So take a look at the first section. We need to find the values indicated and we have a graph, table, equation, and a word problem. So the first thing that I'm going to do is to find the name of each function. So you know that the name is the variable in front of the parentheses. So the name of the graph is M, the table is H, equation F, and the word problem, we're going to be using this equation right here. It's R. Okay, so we're ready to find the values. So on the first one, we have H of -7. So we're going to be using the table. Remember that this number inside of the parentheses is the input, okay? And that is the same thing as the X value. So we're going to go down until we see -7, and then we're going to look at the output, which is -5, and that's my answer, okay? -5 is my output, which is also my Y value, or H of X. H of -7. Okay, now let's take a look at this second one right here, M of 2.70. So I'm going to be using the graph because this function is named M. So we have 2.7, which is right here, and I'm going to go up until I touch the graph, and then I'm going to go over for the Y value. Okay, again, this is the input, this is the output. So my output is a number 1. Alright, F of 4. This time we're going to be using the equation. This is the input. What do we do with the input? Well, we plug it in, okay? We're going to plug it in our equation. So we're going to write F of 4 equal, okay? Anytime you encounter an A, instead of writing A, we're going to write the input, which is -4. The operation between 2 and A squared is multiplication. So 2 times the input squared, and the input is 4. Now we need to continue because we have a plus 3 times A, which instead of writing A, we're going to write the input, and then -5. And now we can use our calculator to type this in and actually find out what it is. Okay, so remember that you need to type it in exactly how it is. So 2 parentheses, 4. This is where you're going to find the squared, right here. Okay? Well, this is where the squared is. Okay? So squared plus 3 parentheses, 4, close it, -5. Okay, and we get 39. So 39 is my output. Okay, we have M of X, which is right here, -3. Okay, so we don't have a -3 here, right? So this is what I want you to do. I need you to change this -3 into a number 5, okay? Alright, so remember, this inside of the parentheses is your input. Whatever is right here is your output. We do not know what the input is, but we know what the output is. And output is another word for M of X and Y. So I'm going to go to the Y-axis and look where the Y is 5. And then I'm going to go over, and then we're going to check what the X value is, and in this case it's 2.90. Alright, H of X is equal to number 2. We're going to be using the table again. This is the input, this right here is the output, okay? So we have the output, we need to find the input. H of X is where we're going to find the outputs. So we need to go down to where we find 2. Wait, we don't have a 2 over here, okay? So guess what, guys? We're going to have to change it again, and I apologize. Instead of h of x equal 2, let's do h of x equal negative 19. Alright, so we're going to go to where h of x is equal negative 19. That means that x is equal 23. Alright, r of x equals 60. Okay, so now we have a function named r. We need to use this function over here. So let's see, are they giving us the output or the input? Well, they're not giving us the input. They gave us the output, okay? Alright, so remember, r of x is equal 12x minus 5. So instead of writing r of x, I'm going to write 12x minus 5. I bring down the equal and the 60, okay? So we just need to solve for x, okay? So the first thing that I will do is to add 5. So we get 12x, this cancels out, equal 65. Now I am going to continue over here. So I'm going to write this again, 12x equals 65. Now we just need to divide by 12 on both sides. So x is a fraction, 65 over 12. Remember that you can press Control, Enter to get the decimal. Okay? So I'm just going to leave it as a fraction, 65 over 2. Okay, let's go to the next one. We have, now we have two functions together. They're joined together by a plus, okay? So we need to take care of h of 10 first, and then we need to take care of r of 5, okay? So take a look at your table. Okay, so what I boxed in blue is a function called h. So I care about the table. Now again, they're giving us the input. So when when x is 10, my output is the number 4. So instead of writing h of 10, I'm going to write 4. Okay? Alright, now I will put it in parentheses, okay, just to be careful. Alright, I am going to bring down now the plus. And now let's find r of 5. So we need to use the function right here. They're giving us the input. That's the input. So that means that we need to plug in. So I'm going to write in parentheses 12 times 5 minus 5. Alright, so I'm going to bring down the 4. And then the plus. Okay. Now we need to type this in the calculator. Can we get 55? So now we just need to add those two together. 4 plus 55 is 59. So that's my final answer. 59. Okay. Now 2 times, remember, I'm going to write it again. 2 times f of 4 minus h of 6. Okay. So I'm going to box f of 4 in one color. And then on the other color, I will box h of 6. Okay? Alright, so I'm going to bring down my number 2. Okay, and I'm going to multiply it by whatever f of 4 is. So, f of 4, we already found that. We know that f of 4 is 39. Now I'm going to bring down the minus. And then we need to find h of 6. We have the input, so let's go to our table. When x is 6, h of x is negative 8. So in parentheses, I'm going to write negative 8. Okay, so 2 times 39 is 78. Now look, we have a minus, and that becomes positive 8. So now we just need to add 78 and 8, and we get 86. So that's my final answer. Okay, take a look at this one. Now we have one more extra step. Okay, we have 2 times m of 3 minus 4 times h of 6. So we need to find out what m of 3 is, and then we need to find out what h of 6 is. Okay, so I'm going to bring down my 2, and then remember that we're going to multiply that by whatever m of 3 is. I'm going to bring down my minus 4, and I'm going to multiply that by whatever h of 6 is. So let's start up with m of 3. So we're going to use our graph. So when x is the number 3, right here, what would be our y value? It would be the number 4. So I'm going to write 4 inside. And then h of 6, right here. The x value is 6, so h of 6 is negative 8. Now we're ready to multiply. 2 times 4 is 8. And then negative 4 times negative 8 is positive 32. When you add those together, you get 40, and that's our answer right here. Okay, question number 9. We need to find the range. Okay, and I'm going to box that. The range, remember that it's y, and y is our output. So please write that down. We need to find the output. Okay, if the function for the given domain. Okay, this is my function right here. Okay, they are giving us a domain, and then domain is our input. Since they're giving our input, that means that we're going to plug that in to x. Okay, so I'm going to make a quick table. Okay, so they are giving us a domain, so I'm going to write negative 1, 0, and 1. And then we just need to use our function to find what this is. So we're going to write, remember that domain is my input, so I'm going to put it inside of the parentheses. And then every time we see an x, we're going to write negative 1. So 3 times negative 1 squared minus 2. And we're going to do the same thing for the other ones. Okay, so this is how it looks like when we plug in the numbers, okay? Now we just need to type this in on the calculator and find out what our actual output is. Okay, so this is our first one. We get the number 1, so let's write 1 over here. Let's go on with the second one. We get negative 2. And then the last one, which is 3, parentheses 1, close it, squared, minus 2. We get 1 again. Okay, so remember that we write our domain, our range from least to greatest, and we cannot repeat numbers. So this is my solution. Okay, question number 10. Again, we're going to find the range for the given domain. So we're going to find the y, the output. Okay, we're going to find the output when they're giving us the input. So remember that when they give us the input, we're going to plug in those inputs in our function. Okay, so let's build a table. Okay, so remember that we're going to be using this function. So we have our domain, negative 1, 0, and 1. That's my input. So we're going to plug it inside of our parentheses, so inside of x. So that's equal. The operation between negative 2 and x cubed is multiplication. So we're going to write negative 2 times the input cubed, so negative 1. And then we have minus 8 times negative 1 again. We're going to be doing the same thing for the other ones. Okay, so now we're ready to plug it in our calculator. Okay, so here we have our first one, and we get 10. So let's write down number 10. Now the second one, is going to be negative 2. Remember to type it in exactly as it shows. The only difference is the number inside of the parentheses. Now, you're going to press this key right here for the exponent. And then you need to press this key to get out of the exponent. Okay? Minus 8 parentheses 0. Close parentheses. Okay, and we get 0. Okay, let's do the last one. Alright, and we get negative 10. So remember, least to greatest, negative 10, 0, 10, and that's my range. Okay, question 11 says, find the domain of the function for the given range. This time we're finding domain, and domain is my input, okay? So that means that they're giving me my output. So whenever they're giving us our input, whenever they're asking us to solve for our input, okay, we need to solve, okay? So remember, since these are my outputs, okay, another name for output is g of x. So instead of writing g of x, we're going to be writing this number. Since we have 3 numbers, then we're going to do this 3 times. So I'm going to start with negative 3. We're going to write negative 3 equal this function, x plus 5. And then we just need to solve. Minus 5, we get negative 8 equal x. That cancels out. Okay, that's my first one. So I'm done. Now the second one is going to be 5 equal x plus 5. We're going to subtract. So we get 0 equal x. Alright, done with the second one. Now let's do the third one. We have 9 equal x plus 5. Subtract 5. We get 4 equal x. Okay, we have all of our inputs, all of our x values, so we're going to write them in our domain from least to greatest. And we don't have any repeats. Okay, so we have another find the domain. So remember that domain is your input. So we're going to have to solve. Since they're giving me my input, I am solving. Okay, so again, they're giving me my range, and range is just another name for output. And in this case, r of x. So instead of writing r of x, we're going to write negative 6, which is this first number, equal to x minus 8. And then we can add 8 on both sides. So we get 2 equal to x. And now we can just divide by 2. So 1 is equal x. That's the first one. So we're done with this one. Alright, now we have 4 equal to x minus 8. We're going to add 8. 12 is equal to x. Divide by 2. So 6 is equal x. Okay. Now the last one, we're done with 4, so we need 8. 8 is equal to x minus 8. So we're going to add 8 on both sides. We get 16 equal to x. The last thing to do is to divide. So 8 is equal x. Alright, we have our 3x values and we're finished. So now let's write our domain from least to greatest. 1, 6, 8.
Okay, to continue our test review, if you look in our little boxes, we're going to sketch a scatter plot for the given correlations. So negative, positive, and no correlation. So negative means that you have 2 data sets that are going in opposite directions, which causes your scatter plot to trend towards the negative direction. So from left to right, your points are going down. So that's negative. If they're going up, so both data sets are positive or going in the positive direction, your graph is going to move in the positive direction. So from left to right, you're going up. And then, of course, no correlation means that your two data sets don't have anything in common. So it's just a bunch of points scattered throughout that has no pattern or general direction.
Okay, guys, so for 14 and 15, okay, we're going to have to practice in class. So before you start your test, we're going to make sure that you know or you remember how to type this in on the calculator, okay? So right now I'm only going to do 14, but I'm going to give you already what M is equal, B, and your R, so that we can answer the rest of the questions, okay? Okay, so this is my X, this is my Y. So whenever we type it in the calculator and we press menu 413, then we find that the slope is negative 1.0445. The y-intercept is 1083.61. And then my R, which is a correlation coefficient, is negative 0.955. Okay, line of best fit. Remember, y equal mx plus b. So we're going to use those numbers and we're going to plug them in, all right? So we're going to write y equal, instead of m, we're going to write negative 1.0445, and then x, and then we're going to write our b. It's positive, so we're going to write plus 1083.61, okay? All right, now what type of association? This means, is it positive or negative? Remember that your correlation coefficient can tell you. If it's positive, then it's a positive correlation. If it's negative, it's a negative correlation. So we have a negative correlation coefficient, so that means that my association is negative. Now the strength. Remember, if it's closer to negative 1 or 1, that means strong. Now negative 0.955 is very close to negative 1, so this is a strong negative correlation. Okay, we're going to do number 15 in class.
Okay, under number 7, solving the literal equations, the first one, solving for y. I'm going to highlight the variable that I'm solving for, so that way it stands out to me. I have 5x plus 3y equals 10. So I'm going to move the 5x first, since it's far away from the y. And I'm going to put it out to the side because that's not a like term with the 10. So this leaves me with 3y equals 10 minus 5x. So from here, I want to get rid of the number that's in front of the y, which is 3. So I divide everything by 3. And this gives me a result of y equals 10 minus 5x divided by 3. If I could simplify any of my fractions or any of those numbers, I would, but that is my final answer, so I'll leave it like that. On B, solve for y, so this time we have 6y minus 12x equals 36. So again, I'll highlight my y value. That's what I want to stand out to me, so I want to get that variable by itself. Now I'm going to have to add 12x to both sides. Add 12x to this side. Now notice that 36 and 12x are not like terms, so I can't put those together. And when I bring everything down, 6y equals 36 plus 12x. I don't put those together because I can't. They're not like terms. And then I'm going to divide everything by 6. Okay, so that cancels over here. So now what I have is y equals 36 over 6. And that part of my fraction, 36 over 6, divides evenly. That equals 6. 36 divided by 6 is 6. Plus, and then the second part of my fraction is, let me change my highlighter color so you can see what I'm talking about. 12 over 6 equals 2. So that becomes 2x. So my final answer, y equals 6 plus 2x. Okay, on part C, you see parentheses. So that means that we have to distribute first. So if I distribute, that's going to be 4x plus 8 plus 8y equals 36. Then I'm looking for any like terms that I can put together. I don't see any that I can combine. And of course, we are solving for y. That's what our instructions state. So moving forward from here, to get that by itself, I'm going to start by moving a couple of things over. And I'm going to start by moving the positive 8. So if I subtract that from both sides, so minus 8 and minus 8, I'm going to have a result of 4x plus 8y equals 36 minus 8 is 28. So I'm going to write that there. Okay, and then don't lose focus of what we're solving for. We want to get y by itself. So I'm going to have to now take a second step and move the 4x over. So if I subtract the 4x, since it is positive, I'm not going to be able to put the 28 and the 4x together because they're not like terms. So now what I have is 8y equals 28 minus 4x. Okay, and then my final step is to get rid of the 8 that is in front of my y value, and I'm going to do that by dividing both sides by 8. So now what I have, I'm going to bring it over here so I have some more room. Y equals 28 minus 4x, all divided by 8. And so if I can reduce, I want to reduce, and I can on this one. So if I look here, I've got y equals 28 over 8. That part of the fraction, I can put, you have to think of what you can reduce your fraction by. So starting with the smallest number, 2 would go into 28 and 8 evenly. And if there was anything else, we would want to consider that. So 4 would be the next largest number, and 4 goes into both of those evenly, and I don't think there's anything bigger than that. So reducing both of those numbers by 4 is going to give me a result of 7 over 2. And then 4 over 8, my second fraction, 4 over 8 reduces to 1/2, so 1/2 x. And that is my final answer. Okay, on D we have 12x plus 3y plus 15 equals negative 12 minus 9y. And we're solving for y, and if I highlight my y values, you can see that there's 2 of them. So of course I'm going to want to put those together. I'm going to draw a line here because that's going to set up what I'm going across or what I have to combine on the other side. So if I move my 9y over, I'm going to add it. And I'm going to put it right underneath the 3y because I want to put those two together. So that'll cancel out on that side. That leaves me with 12x. 3 plus 9 is 12y. Plus 15 equals negative 12. Okay, so now if I look, I've got my y on one side. I've got a 15 over here with the y and a 12x. So I'm going to work on moving those things. I'm going to start by moving the positive 15. And so to put that on the other side, I'm going to need to subtract it. So minus 15 on both sides. That cancels it out, leaving me with 12x plus 12y equals a negative 27. Okay, so from here, not losing focus of that variable we want by itself, y, we need to move the 12x. So it's positive now. If I move it, I'm going to have to subtract it to the other side. And when I do that, those are not like terms. The 27 and the 12x can't be put together. So I'm left with 12y equals negative 27 minus 12x. I'm going to move that over and just rewrite it so I have some more room to work underneath. Okay, so next I need to get rid of the 12. That's going to be my last step before I have it solved for. And if I divide both sides by 12, I'm going to have y equals negative 27 over 12. That's one fraction that I might be able to reduce here in just a minute. And then if I separate my other two, minus 12 over 12, x, I'm going to be able to reduce that one as well. So this is just another way that you can look at your fractions in order to reduce a little bit easier. And so 27 over 12, if you look at that one, think of something that goes into both 27 and 12. 3 goes into both of those numbers, so that's going to reduce down to y equals negative 9 over 4. And then 12 over 12 is 1, so minus 1x or just minus x. And that's going to be my answer. So I'll put a box around that, and there's those 4 literal equations solved for. Okay, on number 8, you have the definitions for discrete and continuous. So let's read those before we answer our questions. Discrete are isolated points that can be counted, and continuous points are connected and they can be measured. So discrete is definitely not connected because isolated means not connected. So these are points that you can't say that you can have like halves or decimals, fractions, anything like that. Connected points are continuous, which is the opposite of not connected. So you have those definitions. It's bolded here. We also wrote it just to help us out. So part A says, Super Sanchez is purchasing candy bars for her coworkers. Each candy bar costs $1. Super Sanchez has 4 fabulous coworkers. So is that discrete or continuous? We would say discrete because our candy bars, what we're actually purchasing here, are counted. So candy bars are counted, not measured. Reasonable domain. So our domain in this situation is the number of candy bars that Super Sanchez is purchasing. So number of candy bars. And so our domain values would have to be represented as a discrete function where we would either purchase 1 candy bar, 2 candy bars, 3 candy bars, or 4 candy bars because she has 4 coworkers. So a reasonable range, when we talk about our range or our output of this situation, our output is going to be the cost of our candy bars. Okay, and so we also have to represent this function as a discrete function. A reasonable range would be $1 if she bought 1 candy bar, $2 if she bought 2 candy bars, $3 if she purchased 3 candy bars, and $4 if she purchased 4 candy bars. Okay, in part B, Mrs. Martin is purchasing strawberries to make a strawberry shortcake. Sprouts has the strawberries on sale for $2.75 per pound. She will be needing about 3 pounds of strawberries. So discrete or continuous? This one is going to be continuous because strawberries are measured in pounds. So when she makes her purchase, she's actually going to be weighing her strawberries to see how much they weigh. And so because of this, pounds are a measurement. So we have to measure our strawberries, and pounds can be decimals, fractions. We can be in between 2 whole numbers and still have an amount of pounds. So we definitely want to say that those are a measurement or continuous. Okay, so for this one, our domain is going to be the amount in pounds that she purchases. So our pounds, she needs about 3 pounds of strawberries. She doesn't need more than that. So we would say anything between, she could purchase anything from 0 pounds to 3 pounds, and we know that our domain is our x's. Since this is continuous, we need a continuous notation to represent everything that is bigger than or equal to 0 and less than and equal to 3. So our domain is everything from 0 to 3 pounds. So she can purchase anything in between that, and whenever she makes that purchase, our range values is going to be our cost. So what is she going to pay for these strawberries? So we know that range is our y values, and if she purchases 0 strawberries, then she spent $0. But if she does purchase all 3 pounds of her strawberries, then 3 times 2.75 is going to give us a total of 8.25 or $8.25. And so we could purchase, or excuse me, Mrs. Martin could purchase anything that's going to cost her more than or equal to $0, because it is possible that she shows up at Sprouts and they don't have strawberries, so it could be $0, or she could find all the strawberries that she needs, all 3 pounds, and she's going to pay right at $8.25 or less than $8.25. And so there is our reasonable range for that problem. Okay, number 9 of our test review is about arithmetic sequences. So our first box is find the common difference. So if we look for our pattern in between our numbers from 9 to 15, that's a +6. And if that pattern continues, which it does, our common difference, or I'm going to call this D, equals 6. On the next one, we go from -15 to -10, from -10 to -5, and from -5 to 0. So each time we are increasing by 5, and so here our common difference, or our D, is equal to 5. Okay, on the next one, it says write the explicit formula for the nth term of the arithmetic sequence, then find a sub 10. So we first need to know what our arithmetic sequence is, and that is our formula, or excuse me, our explicit formula. We need to know what that is. And so our explicit formula is t sub n equals t sub 1 plus d n minus 1. So from this formula, we need to know what our first term is, or t sub 1, and we need to know what our common difference is. So let's figure out what that is. Our first term from our function is given to us as 2, or our sequence. And then D, our common difference, the pattern, we're counting by 5s, but we're going backwards. So it's going to be a common difference of -5. So we need to plug those values in. This is going to replace our T. And then the -5 is going to replace the D. So let's plug that in and see what happens. We've got T sub n equals 2 plus a -5 and then n minus 1. So with our parentheses, the first thing that we're going to want to do is distribute the -5 to give us 2 minus 5n plus 5, and then combining our like terms, 2 plus 5 is 7, so we get 7 minus 5n. So in conclusion, our explicit formula is t sub n equals 7 minus 5n. Okay, and then it says we need to find out what a sub 10 equals. So they're calling our sequence A, and I replaced the A with a T, which that's just the name of our sequence or the name of our function, so that's not a big deal. We just need to know that we need to find the 10th term. So if the sequence continues and I locate the 10th term, n is going to be our nth term in this case. So solving this, 7 minus 50, 5 times 10 is 50, 7 minus 50 is equal to -43. So if this pattern continues, our 10th term is -43. So we found both parts of this problem. Okay, on the next box it says the height of water in a tank each hour after opening its drain can be estimated by the sequence in the table. So our hours after opening the drain, 1, 2, 3, and 4, and our height, 18, 15, 12, and 9, we need to take that data and write the explicit formula that represents that sequence. So you can see I've written down the sequence, and from that sequence, what you need to know how to find is the first term and the common difference. So looking at the table, our output values is where you get your first term or your common difference. So 18 is going to be our first term, our T sub 1. And in between each of these output values, we are subtracting 3, which means that after every hour, we're losing 3 feet from the height of our water tank. So our common difference is -3. And plugging that into our formula, T sub n equals 18 plus a -3, n minus 1. I'm going to distribute my -3 through, and that's going to give me T sub n equals 18 minus 3n plus 3, and then combining my like terms, 18 plus 3 equals 21, so T sub n equals 21 minus 3n. So there's my explicit formula. So then whenever we go to part E and it asks us to find the 37th term, we don't have to just keep this pattern going until we reach 37 hours. We're able to just plug this number into our function, which is going to be T sub 37 equals 21 minus 3 times 37. So 3 times 37. And we'll figure out what this is. Okay, so 21 minus 111, 3 times 37 is 111. If we subtract that, we're going to get -90, which means that after 37 hours of draining the water tank, you're going to have -90 feet, which is not actually possible, but it is possible to find the 37th term. Okay, so just keep that in mind for those word problems or those situation problems. Okay, on F, we have a first term of 3 and a common difference of 11. So in part A, it says to find the next 3 terms of the arithmetic sequence. So I'm going to start by actually writing our first term that was given to us, which was 3. And then from there, I'm going to find the next 3 terms. So if I just keep adding 11 to that, 3 plus 11 is 14. 14 plus 11 is 25. And 25 plus 11 is 36. So there's our next 3 terms, 14, 25, and 36. Our explicit formula, those are the only 2 things that you need. You need T sub 1, which is your first term. That's given to you as 3, and your common difference, or D, equals 11. So to find our explicit formula, we're going to plug those 2 values in, giving us T sub n equals 3 minus 11, n minus 1. And then simplify. So distribute 3 minus 11n plus 11, and then combine like terms. So we've got 3 plus 11, that's 14, minus 11n. So in conclusion here, our explicit formula is T sub n equals 14 minus 11n. That's part B that we needed. And then part C is asking us to find the 30th term. Let me change color so you can see this clearly. The 30th term means that I'm going to take n out of my explicit formula and replace it with 30. So 14 minus 11 times 30. And let's see what we get. Okay, and I realized that I made a mistake, and I hope that you caught this too, but it should be positive 11, not negative 11. So that's going to change a couple of things for us. 3 plus 11 times n minus 1 means that we're distributing a positive 11 through, not a negative 11. So I'm going to make a few corrections here, and I want you to do the same thing on your paper if you were following along with me. First of all, that right there is going to be a negative 11. And then when I combine my like terms, 3 minus 11, that equals a negative 8. So I'm going to erase the 14 that I had previously and put in a negative 8 for that. So let me fix all of this, and then we'll continue by finding our 30th term. And this is going to be plus 11n, plus 11n, and then over here I need to change this. Let me just erase all of this and rewrite it how it needs to be to make it easier for you. Okay, so we're going to have negative 8 plus 11 times 30. Okay, so that should be back on track with what we need. And now we just need to do the math here. So this is going to equal negative 8, and then 11 times 30 is 330. And then when I put those two numbers together, I get negative 8 plus 330 is 222. So over here, our 30th term is 222. And that's the two parts that we needed. Okay, so on part G, the first term is 15 and the common difference is negative 4. So I want you to go through the same steps that we did. On this one, I want you to pause the video, and then whenever you're ready and you finish working on it, I want you to start the video to see if your work matches up with mine. And so that will give you an opportunity to try to do this one on your own, kind of as a you try, but you'll get to check your work in just a minute. Okay, so go ahead and pause the video now. Okay, so like I said, you would be given the opportunity to check your work. So the next three terms should have been 11, 7, and 3. And then using our first term and our common difference, the explicit formula is T sub n equals 19 minus 4n. And then to find the 30th term, of course, we plug that into our explicit formula so we can easily find what our output is. So after the 30th term, we get an output of negative 101. Okay, on number 10, it says to use the graph to answer the questions below. And part A says to draw the line of best fit. So I'm going to put a line through my scatter plot. An average line, so this is without using any calculations and just based on what points I have, I'm going to make my average line look about like that. Okay. So to me, that's the average line. It's just an estimation. Of course, you should have learned by now in your calculator how to go through those steps through linear regression and find an exact line if you're given points. But that's just an estimation. So part B says, is there a causation, and explain? So you have to think back about what causation means, which means that one of the data sets is causing the other one to happen. So if we look at our two data sets, the number of screens and people in attendance. So we have to ask ourselves, is the number of screens, the increase in the number of screens, causing the people in attendance to go up? So my question to you guys that are listening and watching this is, if you increase the number of screens, will that cause the people in attendance to also increase? So if you answered yes to that question, then you are correct. Is there causation? Yes. And that is because, so let me write this out, because the increase in screens causes the people in attendance to also increase. So you can't have an increase in the number of screens without an increase in the people in attendance. So that's causing one to happen. Okay, part C, last Saturday, 75 people attended a movie. Approximately how many movie screens were used last Saturday? So 75 people, that right there is our y-axis. So we need to look at our y-axis and locate where 75 is approximately located, which I would say about right there is 75. So I'm going to draw an arrow that's also pointing to where I'm pointing. So 75, and going across and using my line of best fit, my yellow line, it looks like that is closest to 5 screens. So I would approximate this to say that there are approximately 5 screens used if 75 people attended the movie last Saturday. Okay, and then part D, on Friday, 11 movie screens were used to show movies. About how many people attended a movie? Okay, so this is tricky because we don't have 11 screens on our graph. So I'm going to extend my x-axis out just a little bit to where I can approximate that this would probably be about 10 screens. And, not 100, let me erase that. 10 screens, and this would be about 11. So if I use my line of best fit and I extend on up until I reach my yellow line and I approximate this, I'm going to approximate that, draw my dashes across here, that would be about 140 people if I match that up with my x and my y axis. So just an approximation, I would say about 140 people. Now, you couldn't have 140 people in attendance if the number of screens didn't also increase. So that, again, causation. You have to think about that.